Continuing with this chapter, quadrilateral, understanding quadrilateral class 8, we are now on the fifth question. It says that in a quadrilateral, in the given figure, as you can see, ABCD is given a rhombus, and we are also given the value of angle ADB, and that is 50 degree. And what we have to find are these angles, angle CBA, then we have to find angle BCD, and also this angle called ADC. So let's say, how can we do this question? Where it's gone? Yeah, it's here. Now, as you can see, I've written this value here. That is, this angle is given as 50 degree. And the first part, we have to find angle CAB. That is CAB. This angle is what we have to get. You should know that diagonals of a rhombus bisect each other at 90 degrees. So this angle is 90 degree. This angle is 90 degree. Further, as you can see, this is a triangle. And in this triangle, that is BEA, we know two angles, the value of two angles. So by angle sum property, we can get the third angle, right? So we can say that this is that is angle BAC plus the other two angles we know as 50 and 90 should be equal to 180. That's why angle sum property. So angle BAC will be 180 minus sum of these two, that is 130. Is it 140? This is 140. So we got this angle as 180 minus 40, that is 40 degree. So once we know this value of this angle, now let's see what we have to get the next. So this is, we got as 40 degree. Now in the next part, they are asking to find the value of angle BCD. BCD. This whole angle is what we have to get. Now, first of all, you can see that these two lines are parallel. That is AB. As you can see, this is parallel to this, and this is AC is a transversal. So we can use alternate interior angle property to write this value. So I repeat, we have two lines given parallel. So using alternate interior angles, I can write this angle, only this part of this, right, as 40 degree from alternate interior angles. Moreover, you should know that the diagonal of a rhombus bisects the opposite angle. The diagonals of a rhombus bisects opposite angles. That means this will be equal to this. So therefore, this angle also should be, that is angle BCE should also be 40 degree. So once again, we got this angle as 40 degree by alternate interior angles. And since diagonals of a rhombus bisect opposite angles, so that means AC bisects angle A as well as angle C. So we can say this angle is 40 degree. So now we can straight away say that angle BCA will be 40 plus 40, and that is equal to 80 degree. Now in the later or the last part, what we have to get is angle ADC. This is ADC. This angle is what we have to get. Now we can use the similar way or alternate interior angles and get this value. There can be other ways of doing, but we can find out like this. This angle is 50 degrees. So by alternate interior angles, this will also be 50 degree. Further, as you know that the diagonals bisect the opposite angle. So this angle must be equal to this. That means angle ADB will be equal to angle BDC. As these two angles are equal, we can write this also as 50 degree. Therefore, in the final part, we can write angle ADC as 50 plus 50 as 100. So the property used here, we have used altogether, we have used three properties. Number one, that each diagonals of a rhombus bisect each other at 90 degree. The second we used is alternate interior angles. And the third, that the diagonals of rhombus bisect the opposite angle. These are the three properties used to find the values of the angles that they asked for.